All right. Well, thank you very much, Raki, for inviting me to give this presentation for the Snow Leopard Network. I'll be talking about AI and technology and how we can incorporate that for the benefit of nature conservation. Just to give you a quick overview of this talk, I'll introduce you to some general topics and then discuss a few different technology types and AI applications. And then I'll end with some general tips and tricks. And yeah, I think the whole talk will take about 45 minutes to 50 minutes, and then we can have some discussion and I can answer some questions. I think if you have a question, you can type it in the chat, and I think Raki will discuss them later on. First, a little bit about myself. I am an ecologist by training, so I specialized in forest and nature conservation, and I've done quite a lot of ecological topics before I ended up doing what I do now. So here you can see some pictures of me doing coral research and scavenger studies, and I worked a lot with camera traps myself. And there you see an image or a video of me doing insect monitoring in the Netherlands. And well, when I did all this field work, I came in touch with data sets, and then these data sets became larger and larger. Then I started working with complex statistics, and then one thing led to another, and I started developing my own species recognition models. And at that point, I founded my own company, which is ADAX Data Science. And here we help conservation agencies to improve their workflow by automating different tasks and analyzing data with AI. All right, so technology and conservation. I'm sure most of you already know what technology is, but just really short, technology is generally an electrical device that gathers data for us. And it does so we don't have to sit in the forest the entire time. So you can use it to gather data from uninhabitable places. So for example, with a drone, you can just fly over a swamp, or with a camera trap, you place it in the forest and you don't have to sit there for a couple of months. Yeah, it's also non-invasive. So you gather a lot more data with a camera trap than just sitting there besides the tree. And also a really big benefit is that you get lots of data, which helps us understand the environment and helps us to study these animals. But if you get lots of data, that means that you have lots of analyses, that you have to do lots of analyses. And that's where AI comes in handy. So AI is artificial intelligence, and a subpart of artificial intelligence is machine learning. And I'll talk to you mostly about machine learning. And that is actually that you learn a machine a particular task. And that task generally is recognizing a pattern. And a pattern can be anything. It can be, for example, as you can see here, recognizing the pattern of a jackal in an image, or perhaps the sound wave, the spectrogram of a bat or a cricket or a toad or whatever. So it's just learning the computer to recognize a certain pattern. And that is a big help for data analysis, and it also reduces manual labor quite a lot, which I'll be talking to you in a few slides. First technology method that I want to discuss is camera traps. Of course, most of you already know what a camera trap is, but just for the few that don't, It's an electrical. It's a camera. It's a static camera, and it's placed in the forest or on a pole or whatever, and it just takes images of, like, it's everything that moves. It takes an image, and it's it's estimated that there are at this point about million camera traps in the forest, in nature globally, and each of these cameras take thousands of images every few weeks. So this produces a whole lot of images. All of these images have to be stored, managed, and processed by the organizations that use it. So it's a huge data handling that you'll have to do, and especially because there are so many false triggers. So for all you camera trappers out there, you'll know what I'll talk about. But so for example, if you have this this image, this setup, if there would be a little bit of wind, then the grass would start waving, or the branches maybe, and then the camera would just shoot images. So generally, it's not unheard of if you have a data set with 90 or 95% false triggers. So these would be just empty images without an animal on them. And if you have to sift through all these images, that's really labor intensive. And you probably guessed it already, but a machine, so AI, is really good at deciding whether an image is of interest or not. So it was actually a model developed by Berry, Morris, and Yang. I don't know how long ago, but a few years ago, and they trained a model to detect whether there is an animal on the image, a vehicle, or a person. And it was trained on images from all over the world, so it's really good in with different different habitats, different ecosystems. And if you run that model, it will end up something like this. So it would say, hey, there's an animal on here, or a vehicle, or a person. And if so, then the image is of interest. If there is nothing on there, that it would get the label empty, and then you don't have to look at that, or at least you don't have to spend as much time as you would on the animals. And I think it's really good to note that the model will not tell you what kind of animal it is. It will just tell you that it is an animal. It won't say this is a zebra. Okay, so this model is really good at filtering out the empty images. So I just want to give you a comparison. This comparison was also done by Berry, Morris, and Yang, and they used their model to sift through a data set of almost 5 million images. So you can see the 6 images here. It's just separating images with animals on them and images without animals on them. So a computer run that model over the data set of 5 million images, and it took about 3 days. And if you would hire a person to do this, which would work on this full time, that would take about 8 years to do. So that's a huge, huge difference. And of course, this wasn't your average laptop working on these images. It was quite a powerful computer, but still, it's a huge difference. And then most of you camera trappers are really interested in identifying the animal, of course. But unfortunately, there is no global species model available that can detect all animals on the Earth. And some of you might think, but hey, iNaturalist does a really good job at this. That is true, but I'll talk about that later, because with camera traps, it's a little bit more difficult. But the common thing to do in camera trap land, or at least machine learning camera trap land, is to develop ecosystem specific species models. So you don't have to learn all animals of the entire world, but just you're limited to a set of, let's say, a few dozen animals, which is better, easier for the model to detect them. And then you would use two models in conjunction with each other. So first you'll have an image, then you'll run the mega detector model over it, which would say, well, here I found an animal. Then you crop out the background, so you keep only the animal, and then you run your ecosystem specific classifier over it, and then it would say this is a lion or a zebra, and these ecosystem specific species models, they generally are, well, for an ecosystem, of course, so you would normally say about a country or maybe a part of a continent. And I'll show you, tell you more about that later. This is a software application that I want to tell you about. I developed it myself. It's free to use, and it actually incorporates this pipeline for you, because as you can imagine, this might be hard for people. It's all open source. You can just take it, but it still involves a little bit of programming, and yeah, you'll need to know how to use Python. So I made it easy for people to use these models through my applications called EcoAssist, where you can locate the animals and then identify them. And there are a few ecosystem-specific models. At this point, there are only one of Europe and one of Southern Africa, but there will be more soon. Tasmania, Amazonian rainforest, and New Zealand will be on there soon. Unfortunately, there's no model for a snow leopard habitat yet, but you can still use it to locate animals. So you don't have to use the classifier. You can say, hey, I just want to know which images contain an animal. And then you can filter out the empties. And then you can only look at the images with an animal. So that reduces your workload by quite a lot still. And you can find it on my website, adexdatascience.com/ecoassist. All right. Animal classifiers. How do we develop them? As you can imagine, it's quite a technical story, but I try to visualize it here and make it easy for you. It basically means that you'll have to show your machine, your computer, a whole lot of example images of an animal. So for example, here we're trying to create a classifier which can classify either deer or bird. And then here you see maybe a dozen images, but generally these would be a few thousand images. So you'll just give the computer a few thousand images and you say all of these images are deer and all of these images are birds. The machine will then loop over these images and look at them and try to find comparisons between each other. So for example, the computer will eventually think, well, a deer has I don't know, 4 legs and quite a long neck, and the birds have feathers and a beak. And then after a few times looking at all these images, the computer will say, well, I think I know the difference by now. And then it just pops out a computer file. And that is something like a Word document, but with a funny extension. And I think it's important to note that all these images are not actually in the file. So the file only knows how a deer looks and how a bird looks. So if these images would be about 500 gigabytes, that model file would be maybe about 100 megabytes. And so if you hand over an unknown, previously unseen image of a bird here, and you give it to the model, it will say, well, I think it's a bird, and I'm about 92% sure about that. All right, so we'll just have to add some example images, and then you'll get a species classifier. Well, how much images do we need for that? I briefly discussed iNaturalist before. So iNaturalist is a online database which has similar models. So it's also computer vision models, which work basically the same. But yeah, iNaturalist would need about a few hundred images before it can accurately detect a species. But if you're working with camera traps, that would be, you would need a few thousand images. And the difference is because iNaturalist works with a human factor, and that human factor, that is you taking the image. So for example, as you can see here, this person wants to identify this plant with the red branch, and it makes sure that the branch is in the middle of the image, it's well lit, the focus is all right. So here you can see some training images for iNaturalist of this insect. And you can see that it's really well centered. It's all from the same angle. Yeah. Usually at camera traps, we don't get this, the data with this quality. So with camera traps, you would generally get something like this. This slide is actually taken from a presentation of Sarah Berry, and she really well explains the difficulties in camera traps. So for example, you would have, by the way, all of these images have an animal on them. So you would have difficulty with lightning, or maybe it's foggy and there are like, it's blurry. Here there is an animal too, not sure where it is, but it's really small, behind some bushes, camouflaged, and you see only a very small part of the animal, and the focus is not good. And here you can see the animals. So imagine if a human has trouble finding the animals, let alone identifying the animals, then a computer would have even more difficulty identifying these. All right, so you'll need a few thousand images of every species. That's a really difficult task generally, especially for the rare species. But luckily, there are people from all over the world, conservationists, that share their data so people can use it. And Lila BC is a really important repository for this. So there people store their camera trap data, and every image is labeled as being, well, the species of the animal is noted. So for a study that I did, for a project that I did in Namibia, I was classifying all these species, so about 30 species present in Namibia. And you can see the difference in color. So the red color is were images from the client itself. And the green color was actually images taken from Lila BC. So all of these images for this project, about 80% was taken from the online repository, which is quite a lot. So without this Lila BC, I wouldn't be able to make such an accurate model like I did here. So I just want to say that Lila BC is a huge help. And without Lila BC, we wouldn't be as far with the camera trap machine learning as we are now. And I also want to say, because I told you about you'll need a few thousand images for every species, that's not a hard rule. So as you can see here, like the rare species, they have a few hundred, and a few hundred is also fine, but it would just mean that the accuracy would be less. So for example, the accuracy here of the well-known species would be 98%, and these rare species would be something like 80 or 85%. So there is no hard rule. You'll always have to figure out and try, and generally you'll just use whatever whatever you have and see what model results. All right, another thing that you can do with if you have limited availability of images, and that is you can group certain species together. So for example, a common thing to do is group all the birds together, because there are so many different birds, and generally you just group them together, and then you have one class called bird. So you know on which images the birds were. The benefit is that your accuracy goes up, but the downside is that you'll get less detailed information, because you don't know whether there is a woodpecker on your image or a magpie. But still, if you're really interested in birds, then you'll just have to manually verify all the images with birds, and then you'll be able to say woodpecker or magpie. So still a huge help. And another option is to substitute species. For example, for a project, I worked with the black-backed jackal, and I found that there was a bit limited availability for the black-backed jackal. So I looked around and I found that the side-striped jackal had quite a lot of data, and they look very similar. So I actually took the images from the side-striped jackal and I labeled them as black-backed jackal. So and this is also really important to note. You can only do this if these two species don't coexist in your project area, because if they do, then every side-striped jackal will be labeled as a black-backed jackal, and you don't want that. So if they coexist together, you want to group them like with the birds, and then you would just call them jackal or by their genus name, for example. But yeah, so substituting is a good option if they don't coexist. All right, so we have basically most of the camera trapping work so far has been done passive, where you go out into nature, hang up the camera, leave it there for a couple of weeks or months, and then go back, pick up the data, the card, and go back to the office, stick it in your computer, and see what happened there for these months. But there is a new way of monitoring, and that is active. And that actually, it works with the same camera traps, but these camera traps just send their images that they took to an onboard computer. And on this computer, there is a machine learning model which would analyze the image that comes in. And this can be any model that you like for the project that you're working on. So for example, if you train a model for detecting snow leopard and a snow leopard would walk past, it goes to the computer, it detects a snow leopard, and then sends off a notification saying, at this point in time, at this location, there was a snow leopard. But it also can be for human activity. So for example, it can detect people or vehicles or any kind of animal that you're interested in. And this active monitoring setup actually gives us a lot of applications. So for example, this is a project that I'm working on in the Netherlands. This is the wolf has returned to the Netherlands after about 150 years of local extinction. And same with a lot of different countries in the Netherlands. They occasionally attack sheep and other domesticated animals. So there is a human-wolf conflict, which we're trying to find ways of handling in the Netherlands. And with an active setup, which can detect wolf in real time, you can actually send off a signal to a deterrent, something like this, where it will play a sound or maybe some light flashes to scare away the wolf. So you could hang up a few of these cameras around a village, for example, and if it detects a wolf, the wolf would get scared away before it actually can enter the urbanized area. And another great application is I've done a study for a cattle rancher in the United States, and he actually wanted a fence that could operate without human interference. So there were a lot of wildlife species on his ranch that were migrating, and they would try to jump over the fence. And this, by the way, is not an image of the actual setup. This is just an example of the fence. So these would be very remote areas, and the animals would end up strangled in the fence, and they would die. So we thought about this project that a camera would actually detect whether an animal is wildlife or domesticated. So if a wolf or a bear would come up, the fence would open, and if a cattle would come up, then it would close. So all the cattle stay in their enclosure, and all the wildlife are free to migrate. But yeah, it's you can the possibilities are great, and we can do whatever. Well, a lot of things at least. All right, so briefly, some other image applications, and in particular, drones and satellite imagery. These models, they work the same as the models that I talked to you about with camera traps, but you'll just have to give them different training data. So, for example, the perspective of an elephant on a drone would be very different than the perspective on a camera trap. So if you give camera trap imagery as training data for a drone, that wouldn't work. So it's the same, but you'll have to treat them differently. But anyway, some exciting applications for drones and satellites would be, for example, human activity detection, generally used for anti-poaching, or here you can see deforestation, so you can check whether it's illegal logging, for example, or this is counting of reindeer in Alaska, I think. Vegetation mapping, and just general wildlife counting and monitoring. Another really exciting application would be bioacoustics. So bioacoustics is a microphone that you hang up in nature, and that microphone just continuously collects data. So it collects sounds, and these sounds are then translated to a spectrogram. And spectrogram is shown here. Spectrogram is actually an image of a sound. So it translates a sound to an image. And if you have that image, that means that you can use the same kind of model to detect sounds as you would to detect an image of a zebra, for example. So for the model, it doesn't matter if the object that it's detecting would have four legs and a neck, but it can also be just a gray line, for example, as you can see here. So it works the same. You can just say, I want to detect all sounds of this bird, and then you'll have to label all the sounds of that bird, and then eventually it will start recognizing the pattern. So this is used mainly for, well, only for vocal animals, of course. So mainly for birds, but also for insects and amphibians, and increasingly also for mammals. I don't think the snow leopard is a very vocal animal, but just to give you an example of how this works. And here you can see, for example, some birds detected, and some crickets and toads. And also for bioacoustics, you have passive and active monitoring. So this is a really big study done by Connor Wood. He is investigating the species diversity, the bird diversity in the Sierra Nevada in California, and how they react to what's the word, burning, so forest fires. He placed 1,600 cameras up in the mountain range, and then every breeding season he would collect data. So that's only a few weeks every year, and in these few weeks every year he would collect about 1 million hours of data. So if you wouldn't have the machine learning models that could do this, then you'll have to have quite a lot of budget to hire a team of bird specialists to continuously listen to these type of data before you'll have to start again on next year's breeding season. And then the active version of bioacoustics is really exciting because it works the same as with camera traps. So it just place it somewhere with a solar panel and a microphone, and then it would just gather data. And there will be an onboard computer which would process all the sounds and send you a notification if it detected something of interest. Of course, this is for animal sounds, vocal animals, but you can also do it for human sounds. And for example, you can do engine sounds, or to know when a vehicle drives past, or gunshots, or music, or chainsaws, as you can see here in this image. This is Topher White, and he works with these types of bioacoustics, and he here you can see him where he places such a device to find illegal logging. So he wants to detect chainsaw sounds in the Amazon, and yeah, well, that's really exciting that we can use technology for things like this. See ya. My colleague just left off for Namibia. Have fun.
Thanks, man. Enjoy.
Yeah, all right. So another really nice type of technology is GPS tracking. An organization that I work with a lot is called Smart Parks, and they specialize in GPS tracking. So, for example, colors. Here you can see this wisent with a color and this lion, and what you'll get the results of this would be that you know where the animals are at every given point in time. So you learn more about their behavior, you learn more about their whereabouts, but it's also you can use it to mitigate human-wildlife conflicts. For example, if a certain type of animal would approach a village and it borders some kind of virtual line, then you would get a notification, and you can send off some rangers or people to that place to make sure that the animal doesn't actually come close to the domesticated animals. And not all animals will get a collar, so they do, yeah, well, they do it for a whole different range of animals, and every animal would get a different treatment. So, for example, for this rhino, a collar isn't suitable, so they made a horn implant, so a small device that you actually place inside the horn, which would do the same thing. But they do it for baboons and for pangolins and well, a lot of animals, and every animal will have their own special treatment. And yeah. Then a very important thing about AI would be the interpretation of it. And this is generally looked over. It is, well, let's imagine your natural area. You're an organization monitoring a natural area. So this could be a forest or a desert or whatever, and you place a bunch of cameras in there. And these cameras, these can be microphones too, or whatever, or GPS collars, but let's stick with cameras for this example. And these cameras, they produce a whole bunch of images. Every day you'll get new images. So you can develop an AI model which would analyze all of them, but that still means then you'll convert image data to tabular data. So this can be an Excel file, for example, and because you have so many images, you'll have a lot of rows too. So sometimes you'll end up with several million rows of data, and that still won't give you a very good interpretation of what's going on in your natural area. So that last step, interpretation, is really important, because otherwise you don't have a lot of use of the AI model. And for example, if you would be interested in the whereabouts of your animals, then a heat map would be nice. Or if you want to compare different groups with each other, then you'll need some kind of statistics. And well, it's all really project specific, what you're interested in. But this last step, the interpretation is really important. And then if you, for example, would have this setup with a continuous stream of images, then it really pays off to have this statistics and interpretation step added to your workflow, because then you can have something like this, like a dashboard, which would give you a real-time, or well, not real-time, but every time new data comes in, an update on the health, or yeah, on the things that you're interested in, at least. And we're reaching the end of my presentation, and this is probably the most important slide of everything that I've said, because I told you about AI and how great it is and everything, but please note that AI is not perfect, and it will never will be perfect. So there will always be an error margin, which generally is okay. Human observers will have an error margin too. But there is another thing that I would like to discuss, and that is, I'll do that with this example. So here you'll see an image, and that image is of a giraffe. So this was actually a project done by Meredith Palmer in the Serengeti in Tanzania. And they had an AI model working to analyze all their camera traps. And well, it was working fine and all good. And at one point, a project member looked at this image and saw that there were some yellow-billed oxpeckers hiding or residing in the armpit of the giraffe. And this was a previously undocumented behavior, which is, of course, really important in ethological studies. But the AI model just didn't see it because it was not trained to see this, right? The AI model only needed to say if it was a giraffe on the image or not. So I just want to illustrate that you'll always need to still look at the images yourself. You'll always have to check AI. And a general rule of thumb is that you'll have to double check about 10%. And then, well, then you look for things like this, or you can check whether your AI model is still up to date. For example, if you trained a model on camera trap images which you collected 10 years ago, maybe your organization has new camera traps with a better resolution, different lighting perspectives, which could mean that the model doesn't work that well on new images. Yeah, so generally you want to double check about 10% of your images. And this is my last slide. I'm aware that I'm giving this presentation to the Snow Leopard Network, and I'm also aware that I didn't discuss snow leopard conservation methods really, but I just want to say, because I didn't do much Snow Leopard, or I haven't done any project involving the Snow Leopard. So I just want to use this discussion to discuss potential applications for the Snow Leopard or for other ecosystems where people are from. And these are my contact details. So if you just want to talk about something, you can email me on that email address, and that is the website. And I think you can also contact Raki to get my contact details. And yeah, well, thank you very much. And I'm open for questions and discussions.
Peter, I think you had one question from Frauke. He was asking whether the Eco Assist can also be used offline.
Yes, yes. So EcoAssist is an application. You'll need internet connection to install it, of course. So, and once the installation is done, everything will be offline, except the model. So if you want to use the European model, for example, then you'll need internet connection to download it. But once it's downloaded, then everything can be offline. Yeah, it runs on the processing of your own computer. Yeah.
You have a couple of questions in the chat now.
All right.
Can you see them, Peter? The first one is from Sarosh.
Yeah. All right. Let's see. Okay. Could you please outline the differences between your software and Whiskerbook, Wildcam, and Wildlife Insights? Well, not necessarily, because I'm not aware. I don't know all of these software things, packages, but EcoSyst is developed for offline processing. So most of these, I don't know all of them, work with cloud computing, which is a really good benefit because you can upload your images, and then in the cloud you have a really, really powerful machine which does all the calculations and then send it back to you. But for people that have limited internet connection, that's not an option. And so, for example, you can download EcoAssist and then it will run on your laptop. And generally, your laptop isn't really powerful, so it will take a bit longer than you would do on the cloud computing, but you don't have to upload anything. So if you want to keep your images offline, then I think EcoSyst is a good option. And maybe Whiskerbook, Wildcam, or Wildlife Insights also does that. But yeah, short, I don't really know the differences between these software. All right. Is this tech mostly used for camera trap pictures, or can it be used effectively on videos too? Yes, it can be used on videos too. Videos, you'll have to note that videos actually are a bunch of images like glued together. So an image would generally have about 30 frames a second or so. So if you have a video of 1 minute, then you'll have a whole lot of images. So you can run it on videos, but generally you'll have to, and this can all be done inside EcoAssist. You can say, I don't want to process all the frames, but I want to process every fourth frame, for example, which is generally good. But yeah, long story short, it can be used on videos too. And yeah, you can use it to detect animals on there. Yeah. All right. And then Rebecca. Are we allowed to use screenshots from the presentation if posting on social media? Oh, I think Raki already answered this. Yeah, perfect. Okay, then Giorgio, what kind of a...
Peter.
Oh,
Peter, Rebecca also asked, is there anything that brands could do to support the work you are doing?
oh, wait. Oh, I didn't actually read the entire question. Sorry. Okay, blah, blah, if we social media. It's so good as someone who works with big brands on AI projects to hear about how AI is being used for goods. Is there anything that brands could do to support the work you're doing? Well, that is quite a big question, but the ecosystem application that is it's free, so it's open source. I've invested quite a lot of time and resources to make this possible for everybody. And ADEX Data Science is a big advocate of sharing technology, conservation technology for everyone. So every time I develop a model for a client, the client will be the owner of the model, of course. So, and they can decide whether they want to publish it open source or not. And through Ecosys, I made a network that you can easily share different models with each other. And people get a notification if there's a new model in a new area, and then can just download it and run it for free. And it's really important for me to keep making this free for everyone, because I want everyone to be able to use it. But that also means that there is how to say this, a donation would be great, because I want to keep working on this. But if there would be some kind of financial motivation for me, then I can make more time to work on Ecosys, because at this point I'll have to work on paid. I'll have to shift between paid work and voluntary work. So donation would be really great, and sharing the platform for more conservationists in need would be great. All right. What kind of AI architecture model framework are you using? Well, there are more. I generally use YOLO V8. So YOLO V8 is ultralytics, which I combine with the mega detector model, which is a YOLO V5. But you can also, Ecosys runs on PyTorch and on TensorFlow. It doesn't really matter. It works with different virtual environments, so you can run different kind of model architectures. Thanks for sharing about your wonderful application. Can Ecosys also work on identifying patterns in spectrograms? Unfortunately not. No, that is Ecosys is focused on camera traps, at least for now. I do have plans of making it available for spectrograms too. That would probably mean a different software package, but no, unfortunately not. I would be like to make one, but no, not at this point. Your app is really promising. Please do it also for Central Asia. Well, thank you very much. I would love to do that. All right. Fami, I'm working developing AI-based tech for waste management. I would like to ask, does Ecosys work for images taken from thermal cameras? It does not at this point, but you can adjust it to work for thermal cameras too. So at this point, it's really focused on camera traps because it has the mega detector model incorporated, which the pipeline that I showed you. So first detect whether it's an animal and then say which species it is. And that model only works on camera trap images. So that model doesn't work on thermal cameras. But if you would have a thermal camera model, then you can still run it through Ecosys, but possibly you'll need to add some extra software, like you'll need to add some extra scripts on how to run inference and etc. I would be happy to help with that, or if you're open on doing it yourself, that's also possible. It's open source. You can see all the code. It's on GitHub. You can find the GitHub link on my website, and then you can send me a PR if you want, or just get in touch with me, and then we'll look at what needs to be done for your model to be run through Ecosys too. All right. what are the possibilities with cameras, images for underwater? For example, is it possible to train a model to recognize fish or newt species, for example? Yes, yes, of course. But then again, the mega detector model isn't really trained on underwater images. But I think this is the same story for FAMI. So if you have a model, or if you want to develop a model that can do that, that is possible. And then we'll need to adjust ecosystem a little bit, and then you can run it through ecosystem. Yeah, that won't be a problem. But yeah, not at this point, but there's only some slight changes, and then it should work. All right, Xylona. I've seen images of snow leopards that are super camouflaged to the naked eye. How easy would AI be able to identify them? Is it just a matter of training? Yes, it's a matter of training, but the the model because like a snow leopard is different from a lion and a mountain lion or a cheetah, for example. But for a model such as mega detector, that wouldn't be such a big difference because it all looks it has four legs, two ears, hairs. So it for a model it would be quite easy to detect whether it's an animal or not. And the fact that it's camouflaged, yeah, if it's really well camouflaged, then the model will probably not see it, but a person would probably also not see it. The model is about as good as a person would be. Well, don't take this too literally because I'm not giving any guarantees, but at least on my experiments, the model is about as good as a person and sometimes even better. So I would just say if you have these snow leopards, camouflaged images of snow leopards, just run it through ecosystem and see, just check if the model finds them. And if not, we can fine tune the model to make it better at identifying snow leopards. And if you have a bunch of snow leopard images, I can set you up with Dan Morris, the guy who maintains the mega detector model, to improve that for the next version. Did I understand correct that the main approach is using mega detector for animal detection and then an image classifier for classification? Is this due to better performance than with object detection models or other reasons as well? I'm considering how feasible the use of mega detector is for active camera trap. Yes, so that is actually a good question. Generally, so you'll have a passive and active. As I told you, the benefit of using passive models for passive monitoring is that you'll have a powerful machine. You'll have a desktop computer, which is more powerful than an edge device. So then you can run two models. It doesn't really matter. So you'll have the mega detector model, which is really good, and then a classifier. And the benefit of using these two is that you'll crop out the background, and then the machine has to focus on only the animal and doesn't get distracted about branches and other stuff. So that is the general workflow for passive monitoring. And if you want to go to the active monitoring, it generally gets too difficult, too much processing if you work with double models. And especially the mega detector model, which is really accurate, but also really, really big. So it takes a lot of time, a lot of processing power for the mega detector model, especially if you use it on an edge device, which is an onboard computer. It can take up to, I don't know, maybe a minute, maybe 2 minutes before one image is analyzed. Generally, that is too long. So then for active camera trapping, you would work with different models. Of course, they'll be smaller, but also you'll work with detectors. So not classifiers, but you would train a model to detect snow leopards, for example, and don't use the mega detector model. And generally, these work a little bit less accurate. but faster. So it's just a balance between accuracy and how fast it is. And on edge devices, you'll tend to go to less accurate but faster, because otherwise it won't work. All right, Ashgar. Prey and predator interaction is possible through this model. I'm not sure how to interpret that question, because the interaction is possible in the terms of you can use it to find all the predators, and you can use it to find all the prey. So and then it will give you an insight about on which images you'll have predators and on which images you'll have prey, and how many of each, and throughout the year, and you see lines and everything. But that I think that is how you can study predator-prey interaction through EcoAssist, at least. But yeah, I'm not sure. Does that answer your question, Ashgar?
I think he's left us, Peter, so.
Okay, okay. All right, Frauke. Yes, is there a way to train the model to identify individuals from a group? Chimpanzees in this case. Yes.
And then Nelson is asking elephants too.
Yeah, okay. So yes, that is possible, but then you would actually treat individuals as different species. Or well, yeah, I showed you the example of deer and bird. You'll do exactly the same thing, but then you'll say, this is species. Sorry, this is chimpanzee Alex, and this is chimpanzee Sarah, and you'll just, for every individual, you'll have a different group, a different set of images, and then it will work the same. So the computer will figure out the differences between the chimpanzees individually, but there is an added difficulty if you want to go and identify individuals, and that is generally that these are so alike. So you'll need an extra model in the pipeline, and that is a feature extractor. So and for chimpanzees, for example, the actual what resembles the differences between these individuals is their face. So you would need, as I showed you, that the mega detector, they find the animal, then you'll have the mega detector finding the animal, then a new model finding the face of the chimpanzee, and then a classification which classifies which face the individual belongs to. But yes, that is possible in this with these models. Yeah, but you'll need a whole lot of images of every individual. Same with elephants, same story. I'm not sure which feature is extracted for elephants. I think the ears, so the edges of their ears are really identical. Sorry, these features are really good for individual recognition. And yes, Stephanie, WildMe is actually really good at individual recognition. And if you want individual recognition, I would advise you to go to WildMe, because EcoAssist, at this point at least, is really focused on just species recognition, not individual recognition. And WildMe is really good at this. So I would give that a look. All right, let's see.
I think you can scroll down to Gilbert's question, Peter.
All right. Let's see. Gilbert. Yeah. Can the application identify individual images, for example, leopards, from a batch of camera trap images? Individual animals. Gilbert, are you asking if the model can recognize individual leopard individual number 1 from leopard individual number 2? Or are you asking? Yeah, exactly. Okay. So same as with the chimpanzees and with the elephants, you'll have to look at the species, what feature is remarkable for that species, add an extra model, zoom on that particular feature, and then train a classification model that can identify number 1 from number 2. Sorry, is there available YouTube tutorials? Well, Ecosys doesn't do this for now, but just scroll up a little bit and go to wildme.com or .org. I saw the link there somewhere. Yeah, wildme.org. They are the guys specializing on individual recognition, and I think they have quite a lot of species already incorporated. So I think that is the place where you should go if you want individual recognition. Does it find multiple species together? How does it prioritize, and how does it handle unsure species? It can't say the species, but maybe it suggests a group. Yeah, so it does find multiple species together. So if you have an image of 2 species together, so for example, you would have a lion and a hyena. It would treat these species as different images. So it would just first the model will get an image of a hyena, then it says, well, this is a hyena, and well, sends it back. Same with the lion. So you'll see an image with a lion and a hyena. There's no difficulty with different species together on an image. And if it's unsure about what animals it is, so I told you about the output of a model, and it says, I think it's a lion, and I think it's about this much % sure. You can set thresholds through Ecosys. You can set it all according to your project and to your requirements. And then you can just say, well, if the model is not sure enough, so if everything under 80% confidence, then it will label the animal as unidentified animal. And yeah, so that's how it handles it. And you can run through all the unidentified animals afterwards. So for example, you'll have a data set of 10,000 images. You run the model, and there will be 1,000 animals unidentified. Then you'll have to check those 1,000 images yourself, make sure, that they are labeled correctly, which you can also do through Ecosys. So there's a function where you can say, I want to human verify all these animals, or perhaps I want to only do 10% of this animal, or, well, you can set a lot of things. All right. And then Stephanie. Oh, yeah. Yeah, so the variety hour is tomorrow. I'll be there too. And if you're interested in wildlife technology, then Wild Labs is that's the place to be. So lots of things will be discussed on there, and there will be a variety hour also tomorrow, and I think it's every month. So yeah, that's a great place to start if you're interested in wildlife technology. Is there a demonstration of the use on YouTube? There is not, and there are a lot of things that that are still on the to-do list of EcoAssist, and a tutorial is one of them. But yeah, at this point, it's just me working on this application, so I'm a bit short on time, but it's on my to-do list, and hopefully it will be there soon. But if you want a demonstration, just reach out to me, and we can have a call, and I'll show you how it works.
So that's great. Thank you so much, Peter. And I'm sure you'll have people reaching out to you. Thank you so much for your presentation and your time.
Yeah, No worries. I'm really happy I was able to give this presentation to this audience. And thank you very much, Raki, for giving me this opportunity.
I think you piqued everyone's interest because we had a massive amount of participation today. So that was really good to see. But thank you so much, Peter, for your time. And we will probably get in touch with you to know more maybe about, EcoExist in the future.
Yeah. So for everybody, feel free to reach out about questions about AI models or EcoAssist, and I'll help you as good as I can.
Thank you so much, Peter. Thank you, everyone. Hope to see you all soon. Bye-bye.
All right. Thank you. Bye-bye.